Alright, in this section here we're going to talk about the properties of logarithms, and we're going to get started with an example of, let's say we had log, and I'm just going to say with a base b, some number here b, of x squared. Now this can be rewritten, okay? You can take this 2 and bring it out front. Log base b of x. Log base b of x. Okay? So this is kind of like the power rule. I think that's what we call this. Taking the 2, bringing it out front, and rewriting. Right? And this is extremely important later on in the story, being able to do this. What if we were to say, though, this? Because this is x squared, that means x times x. Alright? Well, if we have two things multiplied together here, we could actually expand this to log base b of x plus log base b of x. And of course this can be rewritten as, because they're both the same, 2 log base b of x. Okay, I'll put a parentheses around that x there. But it's a whole lot easier just to do it this way here. So we take the power, we bring it out front. Okay, rewriting that. Alright, let's look at some more examples. Alright, if I had log of x times y. Now notice that nothing is written right here for the base. So we have to assume that there's a 10 here. Okay, if we don't write anything at all, then that means there's a 10 here for the base. We can expand this as log x plus log y. So you see in the previous problem up here we did that. See, you can expand it that way. As long as there's two variables that are multiplied together. If I were to write log of x squared times y squared, now we should note that this is like a parentheses right here, okay, around both of those. We can expand this to log of x squared plus log of y squared, and of course now we can expand it even further because we can take this power and bring it out front. Log x plus 2 log y. Alright, so when we're taking derivatives in calculus, this is extremely important to be able to do because it makes our work a whole lot easier. So that's something to look forward to when you get to get into calculus. Alright, what about if I had log some number here, base b, of x, y to the 4th, and z to the 3rd. Alright, so let's expand this. Log base b x plus log base b y to the 4th plus log base b of z to the 3rd. Now of course I'm going to rewrite. Take this 4, bring it out front. So you should have known that was going to happen. Plus, and taking this 3 and bringing it out front of z. So that's now been completely expanded. Alright. So we got lots of examples here to work. Okay. Alright. Let's say we had log base b of this time it's going to be x over y. X over y. Alright. So what we're going to want to do here is we're going to want to go log base b of x minus log base b of y. Alright, log base b of y. And you know, I guess I should be putting parentheses around this stuff. Anyway, so as you can see, we have x divided by y here, or x over y. So when we have the division bar here, the fraction bar, we're going to break this up and use minus. Okay, so you might want to maybe remember that, look, this bar here looks like the minus sign. Okay, whatever it takes to get you to remember that. Alright, so let's look at another one here. If I had log base 3, we'll throw a number in for the base this time, x times y over z. Alright, we want to expand this. This is going to be log base 3 of xy minus log base 3 of z. And of course we're not done, because we can expand this first part. Log with a base 3 of x plus log with a base 3 of y minus log with a base 3 of z. Alright, so that's now been completely expanded out. Okay. Alright, let's work one more of these here, and we'll go into something different. Log, let's say base 4, we got the square root of x over 3 roots of y times z. So we want to expand this completely out. We would write log base 4 of the square root of x minus log base 4 of 3 roots of y times z. Now I'm going to rewrite. You know, of course you would skip steps. Whoops, that's not an equal, that's a minus there. Log, but I don't want to skip any steps if you're first seeing this. Or maybe you're just trying to refresh your memory, right? So we take this power and we bring it out front. So we have a half log base 4 of x is equal to, bring this, darn it, I did it again. I don't know why I keep doing that. Minus sign there. Alright, log, oh, we want to bring that 1/3 out front. So we're going to put that right there. Log base 4 of yz. Alright. Now this is the part we got to be careful about. So we have a half, just rewriting. Log base 4 of x, let's remember to write a minus there, not an equal. And then 1/3. Now I'm going to start a bracket here, because I'm going to now expand this part, and this just becomes y, and because this is multiplication here, right, it's going to be a plus log base 4 of z. Alright, and let's do this again. It's 4 of x minus 1/3. I'm going to go ahead and distribute that 1/3 across now. Minus 1/3 log base 4 of z. Of course we can put parentheses around this stuff here if we want. Alright, that's now been totally, completely expanded out from our original. So that one there took a little bit of time. Alright, well, we've been expanding these expressions. Now it's time to go in the other direction, where we're given this piece here and we want to collapse it completely down. Alright, so that's going to be what we do next here. And let's start with this one here. We've got 2, looks like a z, doesn't it? 2 log with a base b of x plus a half log base b of y plus log base b of z. Alright, so we want to collapse this completely down now to one single log function. We have a plus and a plus, okay? So that means we're going to end up multiplying all these guys together. The first thing I'm going to do is I'm going to go ahead and rewrite this first one, because I can take this 2, right, and bring it up here in the exponent, plus log base b, take this half and bring it up here. So we're just going backwards compared to what we were doing the previous problems. And of course, you know, I didn't put parentheses around this, but whatever. Alright, now we can condense this all the way down to one single log function. We're going to have x squared times y to the half times z. And of course we're going to put that all in parentheses, and we can rewrite this if you would like. We can write that and put that in radical form, so that becomes the square root of y times z. Alright, so that's been completely condensed down. Okay, we're going to work, I think we'll just work one more of those. Hopefully you've got you get the hang of it. We got 4/3 log base b again. We'll just use base b plus log by and minus 1/3 log base b of z. Alright. So I'm going to go ahead, let's see, what are we going to do first? I think what I'll do is bring this up over here. So we got 4/3 plus, right, so we take this little steps at a time. So hopefully you don't get lost. Alright, and we got addition here. So don't worry about that. Dragging my pen. We have x to the 4/3 times y, okay, minus left off the 1/3 here, just rewriting this other part, base b to the z. So we have log base b x to the 4/3 times y, and this is going to be over z to the 1/3. Now there was a step I skipped here, and this can be rewritten as log base b z to the 1/3, right? Taking this third back up here in the exponent. Alright, so all of this is in parentheses. I know that's kind of sloppy, but hopefully you get the gist of that. Okay? Let's hope you get the gist. Now, I guess this is an exponential form. We can write this back into radical form. I suppose I'll do that. Log base b. So this is going to be 3 roots of x. We could put a parentheses around this and raise it to the 4th power, I guess, times y over 3 roots of z. Okay. Alright. We could put the whole thing in parentheses, raise it to the 4th power. It doesn't matter. Whichever way. Alright, moving along. We are moving right along here. Alright, what if I had log base 2 times, let's see, 4. Well, what would this possibly be equal to, besides if you just, typed it into your calculator? Well, let's say that it's equal to y. Let's see if we can figure this out from there. I can rewrite this, or we can do it this way. So we could say 2 to the y is equal to 4. And of course, y is equal to 2 then, right? 2 squared is 4. Okay? So that's one way of looking at that, on how to figure out what is this equal to. Another way is, if we were to write it like this, whoa, that's supposed to be a 2 there, not a z, squared. Alright? So if you notice, if the base is equal to this number here, boy, let me rewrite this. Log with a base 2 of 2, and this 2 here is raised to the second power, okay, is equal to y. And I'm going to rewrite this again back into exponential form. 2 to the y is equal to 2 squared. Now, in the very beginning of this section on logarithms, we worked some exponential equations, and when the bases were the same, you would just set the exponent equal. Therefore, y would be equal to 2, as you can see in this problem. Now, if this number and this number are the same number, then it's just going to be the power is going to be your answer. Alright. But what if we had something like log, let's say base 6 of 35. Alright, there's not a way really to write that, and so we're going to use what's called the change of base. The change of base, and there's a change of base formula actually. And how would we evaluate this in a calculator? Well, the way we would do this is we would just break this up, log of 35 over log of base 6. Okay? So as you can see, log base 10 of 6. When we don't write anything here, remember it has base 10. Okay? So we could actually type this into the calculator now and actually get a number. Now, what needs to be known about this is what if I was wanting to graph this guy right here? I wanted to graph this. Well, in most algebraic systems, this won't graph, or in most calculators that I'm aware of anyway. But you would just simply break this up, log base x over, I'm sorry, I keep saying log base x, log of x and log of 6. Alright, then you can graph this. Type in log of x over log of 6, and now you can graph this. Okay, so this is known as change of base, is what this is called, change of base. Okay, so that's extremely important to be able to do that. Let's say that we had, I wanted to simplify 6 log, this is up in the exponent here, log with a base 6 of 2. What in the world is that equal to? We'll say it's equal to y, but I want to write this back into exponential form so you can see this. Okay, so this ends up becoming what? Right, so it's in exponential form when we want to write it in a log form. Alright, so this would end up becoming log 6 is the base of y is equal to log 6 of 2, and therefore we'd end up just getting y is equal to 2.